All right, so let's take a look at our lesson for today. Today we're going to look at geometric sequences and series. First, let's talk about what is a geometric sequence. Let's just kind of throw that out there. So this kind is a type. It's a type of series, sequence or series, either one, that is created by multiplying the same number over and over again. And that number is R. Okay, that's the number we're multiplying over and over again. It's R. So that's the kind of sequence or series that a geometric one is. Let's just, and while we're on that topic, let's talk about what is the difference between a sequence and a series. That's the question that I've asked. You know, we do sequences and series in BC. That's a question that I ask my BC students. What is the difference between a sequence and a series? So a sequence, and we probably have talked about this already before this in this unit, but let's just make sure, you know, talk about it again. A sequence is a list of terms. It's a list of terms. And for us in this, you know, it's usually, for us, it's going to be usually numbers. So it's a list of numbers. It's just a list. It's one column, you know, a number after the other. There's just a list. A series is...
I found this on the web.
Sorry. Sorry, Siri. I'm not talking to you. I'm talking about series. A series is adding up the terms of a sequence. Okay, so that's where we're summing them or adding them up. That's the difference between those two words. It involves the same terms. It's just we're doing something different to them. Either we're listing them or we're adding them. That's the difference. Either we list them or we add them. All right, so let's go specifically into geometric. So this is a formula right here that we're using for geometric, this formula. And this formula is common for Precal. This is the normal Precal formula. So this is the formula we typically use in Precal. It's not the only formula possible to be used. It's just the one we typically use. So, but there are others or other options, shall we say. There are other options that we use in calculus, such as a sub n equals a times r to the n, where the first term is starting with an n equals 0. Okay, so that's just something to note, just so that you're aware. This is just common for us in this course. We're going to use that particular formula, a to the n equals a times r to the n minus 1. But it's not the only one possible. Okay, so it's not the only one possible. Actually, a more common one used in calculus is a times r to the n. Okay, so that's talking about this formula. This is our nth term formula, where a is the first term and r is the common ratio. Okay. And of course, the common ratio is this whole business R. R is the common ratio. So that's our nth term. What does our nth term formula find for us? It finds terms for us. That's what it finds for us. Now, let's look at two other formulas. These are our summing formulas. The first one is a partial sum. It's a partial sum formula. It's what we would do if we wanted to add up a specific number of terms. You know, like 25 terms. Maybe we want to add up 25 terms. We're going to use that formula, where A is the first term and R is the common ratio. Both of those R's are the common ratio. And N is the number of terms. Okay, so that's all of, let's make that a little bit bigger so we can see it. Okay, so that's what all of those letters mean. A is the first term, R is the ratio, the common ratio, and N is the number of terms we're adding up. So we use this formula if we have a specific number of terms. I didn't even finish my spelling. Specific. Sorry, the English majors out there. So sorry. Kind of misspelled. So that's what we would do, adding a specific number of terms. But it is possible, actually, in some instances, to add an infinite number of terms, which really seems kind of not possible. That we could add up terms that never stop. So just so that we are clear, let's just make ourselves a note here. For infinite arithmetic series, there is no sum. You can't add them up. It does not converge. That means no one is going to ask you to add up an infinite number of terms of an arithmetic series. It's not going to happen. There isn't one. But for some geometric series, it is possible to add them all up. For some, just a few of them. The ones where, and let's just kind of these. The ones where the absolute value of R is less than 1, which translates to be basically R is between -1 and 1. Those, strangely enough, we can add all the terms up and get an actual sum. Okay, we can add all the terms up and get an actual sum. So how do we do that? Well, we have a special formula that adds up all the terms of an infinite geometric series whose R value is between -1 and 1. And that's this formula right here. This is the formula that we would use only for infinite geometric series whose R value is between -1 and 1. If we tried to use this on any other geometric series, it's going to give us a number, but it's not going to be correct because you can't add them all up for any other kind unless R is between -1 and 1. So what are the parts of this formula? R is the ratio, and A is the first term. Okay, so I'm going to pause here for just a second. So we've talked about the three kinds of formulas that we're going to use with geometric. We have our nth term formula right up here that finds terms for us. We have our partial sum formula that finds, say, the add of the sum of the first, I don't know, 15 terms or something. And then we have our third formula, which is for infinite geometric series whose R value is between -1 and 1. And that's the overview for today. That's just the concepts that we're going to be looking at. Are there any questions for me? Okay. So for this lesson, it would be helpful if you had your calculator. I mean, you don't have to have your calculator out to work the lesson through with me because I've already done the calculations, but you will need a calculator for this kind of work. So let's jump into our work. Really, this first question is probably the hardest one. So why not? Let's just go for it. This is probably the hardest one, and let me explain why. All right, so what are they wanting us to do? They're giving us the third term, which is this, and they're giving us the sixth term, which is this. Okay, great. And they're asking us for the fifth term. Now, if this was arithmetic, it would be pretty easy to find the common difference. We did that before, right? It doesn't matter if the terms are separated from each other, if it's arithmetic. Easy. We use our little formula, that special formula that we looked at last time, where D is the difference between the terms and the difference over the difference between the terms numbers. Great, we got D. That is not how it is with geometric. It is much more difficult with geometric. So let's go through the steps that we would need to do to be able to find out all the information that we need to write our formula if it's arithmetic. Excuse me, if it's geometric. So first off, let me write our formula up here. So a sub n is a sub 1 times r to the n minus 1. That's the formula that we are using. So how do we do this with geometric? Okay, how do we do this with geometric? What are we going to do? Well, we're going to actually take each of the terms and plug them into the formula. Each of the terms and plug them into the formula. So let's do that. So and I'm actually going to, it just would be easier for you to do the latest term first. So the latest term is the sixth term, so I'm going to do it first. So I'm going to write the sixth term down, 1701 over 32 equals, so I'm filling in the a sub n part. I don't know what a sub 1 is. I don't know what my common ratio is, but I do know that this is a sixth term. Okay, and I'm going to write that first. Now I'm going to do the same thing with the third term. So the third term was 63 over 4. I don't know what the first term is. I don't know what the common ratio is, but I know that's the third term. All right, so this is step 1. I'm just going to put a number by it. That's step 1. We write out the terms inside the formula. The next thing that we're going to do is we're going to divide these. That's step 2. We're going to divide the two equations. Now, dividing equations is something that we don't do all the time. In fact, we don't do it hardly at all. We add equations together and we subtract equations, but dividing equations is not a thing that we typically do, but that we're going to do that now. So I'm going to rewrite them and we're going to divide them. And so let's see what that entails. How in the world can we divide equations? Well, what we have to do is we have to make sure that the equal signs are lined up. Okay, the equal signs are lined up, so we're good to go. We're allowed to divide these equations. Okay? The second thing is, I know that if I have like 2 over 2, that's 1. So A1 over A1, I'm going to divide those out so that I can get it down to something that I can work with. So what does that give me? That gives me, let's go over here. So in my calculator, I would take 1701 over 32 divided by 63 over 4. I would do that in my calculator. I certainly do not expect you to do that in your head. That would be crazy. So when I do that in my calculator, I get 27 over 8. That's what I get when I divide those two fractions together. Now let's think back to our exponent rules. If I have r to the 5th over r squared and I divide r to the 5th over r squared, what am I going to be left with? R cubed, exactly. I'm going to be left with r cubed. So now we are finding r. That's what we're doing. When we divide those, we are finding r. Divide these to find r. We need our common ratio. Unfortunately, it's not an easy matter like it was with arithmetic. So now I would cube root both sides, right, to get rid of that 3. Or you can think about it as raising each side to the 1/3 power. That's the same as cubed rooting. So the cubed root of 27 is 3, and the cubed root of 8 is 2. So that calculates my r. I now have my r. And when you're working with geometric sequences that they're giving you terms that are not next to each other, that is your only choice. Well, there are other choices, but that is the choice that we would use right here. That's the technique that we would use to find r. So what is it that we're really doing? What we have are 2 equations and 2 unknowns. That's what we have, 2 equations and 2 unknowns. It's a system of equations. We just solved a system of equations for r. Now we need to go back and we need to find a sub 1. We need to find a sub 1, because what if they ask us for the 50th term? We would not be able to do that by hand. So I need to show you how we need to keep going. Okay, so I'm just going to draw a line here. So the first part we use, that's our steps. We wrote each term that we were given inside a formula, then we divided them to find r. Now we're going to step 3. We're going to find a1. You're going to choose either one of those formulas. I'm just using the easier looking one. I'm going to use the 63 over 4 equals a1 times r is 3/2 squared. And then I solve for a1. Okay, that's what we're going to do now, is we're going to solve for a1 by dividing both sides by 9/4, right? 3/2 squared would be 9/4. So we're dividing both sides by that, and that gives us that our a1 is 7. So that's our third step, is to find a1, which is 7. Our last step, step 4, is to find a sub 5, our 5th term, because that's what they asked us to do. They asked us to find the 5th term, which is a sub 5. That is our last thing that we're going to do. So we plug into our formula. First of all, let's create our formula. A sub n equals 7 times 3/2 to the n minus 1. There's our little formula. We plugged in the 2 things we needed to find, which was a1 and r. Now we're going to find our 5th term. So a5 is 7 times 3/2 to the 5 minus 1. And so we use our calculator to do that. And so the 5th term happens to be 567 over 16. So just know, if you're going to be allowed to use a calculator, which you will, because there's a lot of things you need the calculator for, the numbers you put in there are not going to be easy, otherwise you wouldn't need a calculator. Does that make sense? The calculator is used for really difficult numbers. So you're going to have some weird numbers. All right, so that's the first, that's like the hardest thing right there, is finding, basically finding the nth term when your terms are so spread apart, right? I got the 3rd term and the 6th term. Well, that's not very easy. All right, questions on number 1. All right, number 2, they want us to find the sum of the first 10 terms. So that means we're going to use our partial sum formula. which let's write that up there. That was S sub n equals A times 1 minus r to the n over 1 minus r. That is the formula we're going to use to find a sum of a particular number of terms in the sequence. So here, let's, first of all, what do we need? We need the information we need. We need to know what is r. We need to know what n is, and we need to know what a is. Those are the things that we need in order to find our, use the formula. Okay, so some of them are pretty easy. So it said 10 terms, so S sub 10 equals, that's our first term, which is a 1, times. Okay, now r, we need to find r. So these terms are right next to each other. So to find r, we take the next term, divided by the term in front of it. Okay, or maybe we didn't like that. Maybe we should have, I mean, it really doesn't matter. You could have done 0.49 divided by 0.7, and you're still going to get 0.7. So our common ratio, no matter, I mean, we could take these two and divide those. The key is that you take the term that's farthest away on top, like the third term divided by the second term, or the fourth term divided by the third term. That has to be on top, or your ratio is going to be upside down. Okay, your ratio is going to be upside down if you don't put it in that order. So our common ratio is 0.7. Great, so we do 1 minus 0.7, and that n was 10 to the 10th over 1 minus 0.7. And this we would just simply put in our calculator. This isn't something that with numbers like that, we wouldn't be doing this by hand. So I take that and I put it in my calculator, and I get 3.2392. Okay, your answer, and we've been talking about this all year, but I'm going to be, your answer needs to be to the thousandths. Why is that important? That's important because your answer in calculus needs, the default is to the thousandths. You just need to become accustomed to writing your answer to the thousandths, because you will lose points if you don't. So we're starting that, we started that this year and last year. We need to write to the thousandths. So S sub 10 is going to be 3.239. Okay? Questions on using the partial sum formula. All right. Let's go to our next problem. This one is weird. First of all, let's kind of understand what it's asking us to do. So what's it asking? So this, our term, we're going to start at term number 1, because n is 1, and we're going to end at term infinity, which, your calculator can't handle that. Don't even try to do that. Okay, well, we just talked about infinite series, right? What's the only kind of infinite series we can actually even add up? Geometric. And in the geometric, that's the only one we can add up that we're working with this year is geometric. And not just any geometric, only the geometrics that have an r between -1 and 1, right? So we're kind of stuck a little bit. So the first thing that we'd want to do is we want to rewrite the way this, so recall this little Greek letter, this sigma, means sum. It's telling you to add stuff up. That's what it's saying in math language. So let's rewrite this. So we're going from 1 to infinity of, this doesn't have an n attached to it, so I'm going to put it right here, and I'm going to put the 1/5 to the n. So I want to make sure we're all okay with that rewrite. So in this case, we would need to rewrite it so it makes more sense as to what we're doing. So the 2 is not to the end, so it goes out front. Then I have 1/5 to the end. Okay. All right, we can do that. So here, let's look and see what we got. So that's R. R is 1/5. Okay, to do this, we need R to be between -1 and 1. Is 1/5 between -1 and 1? That's the question we have to ask ourselves. Is it between there? It is. So we can add this up. We can. So now we're going to use our formula. Now I'll write it up here. So that was S equals A over 1 minus R. And let's fill it in. Now here is a big caution. A big caution. 2, in this case, is not the first term. I want you to notice how this is written. It's written to the n, not to the n minus 1. So in order to find, we need to find the first term. Okay, so let me erase this. We need to find the first term. Okay, how do we find the first term? What do we do? Well, we take our little formula and we put in the first term number, which is a 1. We put that in, okay, to the 1. That's our first term. 2 times 1/5 to the first. 2 times 1/5 to the first is 2/5. So our first term is not 2 in this case, it's actually 2/5. Really important that we don't assume that the number sitting there is the first term. It is a lot of the time, but it isn't always. I'm going to pause here for a second. How are we with finding the first term? Is everybody okay? Okay, so let's fill in our formula then. So S equals, our first term is 2/5 over 1 minus, and R is 1/5. Now, when we work that out, that's going to be our sum, whatever that is. If you have a calculator, you can stick it in a calculator. If you don't, we can certainly do this by hand. It's not that hard. So I've got 2/5 over, let's see, 5/5 minus 1/5 is what, 4/5? Then we keep, change, flip. Remember how we fix complex fractions? Keep, change, flip. We keep the top. We change division to multiplication and we flip the bottom. Keep, change, flip. So that gives us 2/4, which reduces to 1/2. So crazily enough, if I add up all of the terms that I even come across, I'm going to get 1/2. Okay, how are we? We okay on that one? All right, last one. Determine whether the geometric series converges or diverges. If it converges, find the sum. Okay, so how do we know whether geometric series converges or not? What are we looking for? What are we looking for? What are we looking for? Okay, I could call a name, but I just want you to tell somebody, tell me, what are we looking for? How do I know if a geometric series converges? All right, so what does it mean to converge? What does it mean to converge? It means that you will have a number for an answer. A number like 5. Not a concept like infinity, okay? What does it mean to diverge? It means those will have an answer that is either infinity or negative infinity or something undefined. That's what that means. So diverging means that you're basically not going to get a normal answer. It's going to be weird, like infinity or negative infinity or undefined. Converging means when you add it all up, you're going to get a number for your answer. You will get a number. So when we're asking if this converges, we're asking if I were to add an infinite number of terms up, would I get a normal number answer, or would I get something impossible like infinity or negative infinity or undefined? That's the question that we're asking. And we discovered when we were talking about these that only one kind of geometric series has an answer for an infinite sum. Only one kind. And that's the kind where R is between -1 and 1. That's the kind we're looking for. That's the only kind that will converge, is the kind of infinite geometric series where R is between -1 and 1. That's what we're looking for. So as we look at this last problem, we identify what R is. So this is R. Okay, that's R. Is R between -1 and 1? Question mark, that's what we're asking. Is 2/3 between -1 and 1? Yes. So we're going to say converges because R equals 2/3, which is less than 1. That's why. R equals 2/3, which is less than 1. So our sum is going to be our first term. Okay, so let's find our first term. The first term is going to be, we're going to put in the 1, so it's going to be 2 times 2/3, the 1 minus 1. That's our first term. So 2/3 to the 0, that's 1. So 2 times 1 are 2. So in this case, that random little number in front is the first term. But it never hurts to test it. So S equals the first term, which is 2, over 1 minus the common ratio, which is 2/3. Okay, so we have 2 over, so 3/3 minus 2/3 is 1/3. We keep change flip, and we get 6. So the sum of that infinite geometric series is 6.